Hello, everyone. My name is Ricardo, and I'm one of the co-founders of Neutrino AI. And we are building the infrastructure for multi-model AI applications. As we know, LLMs are not perfect. Sometimes they hallucinate, sometimes they mess up, and their errors compound with application complexity. Take, for example, querying an LLM directly, where you may see something like 90% accuracy. Now, scale this up to a more real use case, such as an agent, with many dependent LLM steps and moving parts. Here, you may see something a lot closer to 35% accuracy in production. So you improve your prompt engineering, use the largest, most powerful model, but then you're stuck with an application that's too slow and expensive to run. You could also spend time manually finding what are the right models to use for your application. This involves setting up benchmarks, evaluations, to figure out the right combination of model, provider, and orchestration strategy to best leverage these models. And this is a lot of time spent on something that's not really core to the business. It's also a recurring problem that needs to be repeated over and over again with new model releases and changes to the application that may impact model performance. And this is only made more difficult with the fact that the number of models is exploding. An abstraction over the model layer is inevitable. And that's exactly what we're building at Neutrino. We're letting developers automatically implement the best model layer for their AI applications. And we're doing so in 3 main steps. First, the developer creates model configurations for every component of their LLM application, defining cost, latency, and reliability requirements. Then, Neutrino benchmarks all models to figure out the optimal set of orchestration strategies to use. Take, for example, this hypothetical agent, where for the first LLM step, Neutrino identifies Llama 3.8 billion as the optimal model to use. But for the second step in this agent, Neutrino chose to train an auto router to intelligently select between a weak and a strong model based on the query complexity and domain. The end result is a tailored model layer that is faster, cheaper, and more accurate than using any single LLM across an application. And our approach is resonating already. We've done 2 enterprise design partnerships. We've gotten inbound and developer signups from even more enterprise companies. We've released a developer freemium tier with over 1,500 signups and over 300,000 queries processed. And we're strategically onboarding from our developer tier into our full platform beta. And our product works. We can consistently increase supported concurrency, slash costs, improve quality, and decrease latency across a variety of use cases in production. And what we're building is a model orchestration platform, which is fundamentally different than the competition. Because building a router is only part of the solution. And by taking a more granular approach, one that is specifically tailored to an application's requirements, we can consistently outperform existing model routing solutions. And this is a huge market. Companies will soon be making as many calls to LLMs as they currently are to databases. And here, we earn a small cut on every dollar spent that is in this category, similar to how payment processing and routing companies earn a margin on every dollar flowing through their platforms. My co-founder, Ian, and I have known each other for 10 years. I have experience in NLP and quant research at Penn and JP Morgan. He has experience scaling infrastructure at Morgan Stanley and Rockefeller Capital. Together, we built ML systems, LLM agents, and developer tools, and we know the challenges that developers face taking AI applications to production. Soon, AI applications will be powered by distributed inference, with different models running across different devices. And as AI workflows get continually pushed to the edge, small, local models will be increasingly used for simpler queries, and larger, more powerful cloud models will be more sparingly used for the more complex reasoning workflows. Neutrino is building the infrastructure to power this future and power applications built with multiple models. If you're excited about what we're building, we'd love for you to join us. Thank you.